After watching the manufacturing process of ultra-large steel plates, I finally understand just how formidable modern industry is. In the rolling step alone, the facility uses supercomputer AI and brilliant visual analysis to craft the steel plate's dimensions horizontally and precisely. The extreme 3,000-degree temperature reduces metal to ashes, and when the finished product emerges, its craftsmanship will exceed your imagination. This is one of the world's top 50 steel manufacturing bases. The first step in making a steel plate is to place collected scrap iron into a transfer furnace and then add an appropriate amount of alloy elements to enhance the plate's strength. Next, it is moved into the smelting workshop. Don't be fooled by the electric furnace's modest size. It can hold 200 tons of metal. Fierce flames erupt as soon as the scrap iron touches the stove, and the door must be closed to allow the electrode to return to its preset position. Once the green light on the screen turns on, press the start button with force, and the workshop will transform into a refining furnace. This is where the graphite electrode works its magic. Remember, graphite electrodes can produce temperatures as high as 3,500 degrees, and only such rapid extreme heat can melt iron into liquid. The thick black smoke shows the intense battle inside the furnace. After thermal treatment, the scrap iron finally surrenders and turns into a pool of liquid, slowly flowing into a ladle. At this point, the molten iron has reached 1,600 degrees Celsius. But you'd be mistaken if you think it's ready to be cast. A worker uses a 5-meter-long iron rod to scoop out a ladle of molten iron, quickly runs to the pool, and immerses it in water for low-temperature cooling. After it returns to room temperature, the sample is moved to the front by equipment to prepare for metal testing. This step is what we call metal quality inspection. After surface milling, the metal density can be observed, and the data for each batch is recorded. Returning to the workshop, a worker installs the casting spout below as the ladle reaches its preset position. The molten iron splashes into the mold, quickly cooling on the surface to form a thin shell. This thin-shelled billet is continuously drawn out, transforming into the giant steel body before your eyes. It's important to note that billets don't have to be rectangular. They can also be square or round. The billet can be continuously drawn out if the molten iron keeps flowing. In no time, it will be split into two. Due to its large size, it cannot be used directly, so it is moved to the front for secondary cutting. The cutting equipment and rollers are preset with precise data, ensuring that every piece is within the predetermined weight range. The billet surface is observed to be cooled mainly by now, so grinding is done to remove surface oxide scales without causing too many scratches. Now we move on to the secondary heating process, also known as tempering, which is the final step before hot rolling. This transformation increases the billet's strength, enhancing its tensile resistance during rolling. The maximum tensile strength can reach an astounding 1,600 MPa, and the steel strength during stretching will be displayed at the end. With the secondary oxide scale cleaning complete, the hot rolling process begins. Despite its complexity, this process can be handled by a single person. Let's step into the control room, which is a temperature-controlled environment. Compared to the scorching conditions outside, it is comfortable here. After each roll, specific data, including thickness parameters and the number of rolls, is reflected on the screen. However, this is not a one-time process. After dozens of rolls, the thickness must be reduced to 1/20 th of its original size. As the thickness decreases, the length multiplies. Before entering the straightening process, a basin of water is poured over it. The purpose of straightening is to use the hot straightening machine to make the steel plate as straight as possible, with no bends visible on the surface. To ensure the exact values, workers even squat down to check the level, a job that's both tiring and repetitive, especially when a large volume and overtime is required. At this point, the steel plate is exceptionally straight, and the surface is very smooth, but the rolling process on both sides still leaves traces. The equipment automatically removes these. First, a single segment is pressed down, then extra parts are cut off. This steel plate weighs about 5 kilograms, but it won't go to waste. It will be collected in a box for future smelting. In no time, the steel plate is entirely cut and the edges and corners are elegant. However, quality inspection is indispensable in a steelmaking process as stringent as this. A worker retrieves a formed steel plate, clamps both sides, and begins tensile testing, with specific data displayed on the screen. This batch of steel can only be released to the market when it breaks under the required strength. The fractured steel plate is stored in the warehouse for future reference in case of any safety issues. Each batch's data is unique. What do you think about steel plates produced by such a modern enterprise?